Hello and welcome. My name is Chet Burgess. I'm a principal engineer in the developer experience team at Cisco Systems as part of the Cloud and Compute business unit. And today I'm going to talk to you a little bit about how the developer experience team helps to embed security and automation to make it easier for our developers to do their job. First, let me talk a little bit about what the developer experience team is and what it does. Our goal is to enable our engineers to deliver greater product value by focusing on reducing the friction that can be caused by things like tooling, process and procedures, and compliance, which we're going to spend some of this presentation talking about. We do this by applying an engineering and product level approach to what we do. By this, I mean, we view ourselves as delivering a product to the other engineering teams, and we treat them very much as our customers. We listen to their feedback, and we work with them in partnership to make it easier for them to deliver their products. Just a couple of the things that the developer experience does or supports. So we run a number of engineering labs for our product development teams. This is everything from the physical, racking and maintenance of the servers to doing the networking and supporting the operating systems or the virtualization layer. We also help support their CI and CD pipelines. So this can involve things like running Jenkins and running very large build farms. We also support various developer services. This can be anything and everything from artifact repositories to supporting software or endpoint scanning solutions as part of security. And finally, we develop and release automation continually to help enable all of these activities and in general make our developers' lives easier. Now, the developer experience team is a very small, dedicated team of engineers, and we come from a very wide background. Based on the stuff that I just told you that we did, we obviously have everyone from data center specialists to networking specialists, DevOps specialists, compliance people, as well as project managers. We tend to, each member of the team tends to have a very wide background and have a lot of experience doing a couple of different things so that we can easily switch between the type of tasks that we're asked to do. And finally, we support the delivery of various types of product offerings. So some of the product teams we work with ship very traditional looking software where it's something that's put up for download and the customer downloads it and installs it in their data centers. We also support teams that deliver software as a service solutions, and we even support teams that deliver hardware products. So earlier I talked a little bit about compliance, and let's dig into that a little bit more. So broadly, compliance can mean a lot of different things, but I like to boil it down to three primary obligations when we're talking about compliance. Ship only the software you need. So this one's pretty simple. Don't include software that you don't need in your product. And as an addition to that, make sure that the software you do need is configured appropriately to only enable and do the things you need it to do. Number two, keep your software up to date. Again, this is fairly simple. If you ship a component, you need to make sure that you have a way of shipping updates to that component so that if there's a bug or a security issue with that component, you can quickly deliver an update for your customer. And then finally, one of the parts of compliance obligations that I want to dig into a little bit more is what's called open source software compliance. So let's dig into that topic a little bit, right? Open source software is something that we're all familiar with in DevOps and across all of IT. We use most of us use open source software all the time and every day, oftentimes without even realizing the components that we're using are open source or fully even understanding what open source for that component actually means. So open source software exists within a legal framework that creates obligations for both the developers and the distributors. What this means is every piece of open source software you use comes with its own license, and those licenses have requirements that you have to meet as a developer or a software distributor. Now, not all licenses are as open or as free as you might think. There's been a recent trend in both what's called source available licenses and what I like to call open-ish licenses. An example of this open-ish licenses would be what's been happening between, say, Elasticsearch and AWS of late. Additionally, licenses can differ based upon how you intend to use the software. What I mean by this is, of course, that some licenses allow you to do something with a SaaS that you couldn't do with, say, a traditional piece of software that's just linking against that, or vice versa. Something you can do when your software just wants to link against an open source component may not be permissible if you're then delivering that as a service. Finally, I want to call out that the Linux Foundation has a great site set up to really help people begin to understand what open source software compliance is all about. And they have sections set aside for developers, distributors, legal specialists, and it's a very great resource if you haven't checked it out or you have additional questions about open source software compliance. So how do we meet? So Cisco faced this problem a few years back where we said to ourselves, we have all these new container-based products and container-based platforms. And so how do we meet these compliance obligations for containers? And we set out to try and answer that question for ourselves. So one of the early things we decided was that the SBOM, or what we call the software bill of materials, was going to be key to being able to meet all of those compliance obligations. After all, if we don't know what is inside of the containers we're shipping, how do we know if we're only shipping what we need? How do we know if it's up to date? And how do we know if we're complying with the licenses that those components have? Additionally, one of the keys to having a good software bill of materials is that it has to be a complete inventory of all components you ship. Now, what do I mean by all components? So components can be broken down into two categories. There's the first order components. This is what your product directly uses. Many developers or engineers know how to answer this question either off the top of their head, or they have a configuration file that they store along in their source code control system that basically defines the dependencies of their software. So in the case of something like Python, this is typically something like a requirements.txt file that has a list of the Python modules that the product you're shipping needs. Now, what most of these solutions do not include is what we call the second order or greater components. This